Alright, so here's my second video on doing integrals using trigonometric substitution. Okay, so I went over these in the first video. If you have a square root of a squared minus u squared, you'll let u equal a sine theta. And if you have square root of a squared plus u squared, you'll let u equal a tangent theta. And square root of u squared minus a squared, you'll let u equal a secant theta. Okay, so these are the guidelines that you go by. And like I said in the first video, basically what we're doing is getting the radical out of the integrand, getting rid of that radical. Alright, so let's take a look at this second example. Alright, so I have the integral dx over square root of 4x squared plus 1. So this, if we look at it, we can see that it's in this form here. Okay, and actually what we have with the square root of 4x squared plus 1, we have u squared plus a squared, but I mean that's the same thing, a squared plus u squared. Doesn't matter which way it's written when there's a plus sign in there. Okay, so we know to let u equal a tangent theta. Alright, so let's go back to the problem. Alright, so like I said, we have the square root of a squared plus u squared. Okay, so here's our a squared, here's our u squared. Okay, so remember, this can also be written as the square root of 2x squared plus 1 squared to get it in this form. Okay, alright, so we're going to let x, well, not x, but we're going to let 2x equal a, which is 1, times tangent theta. Okay, so now if we integrate, we get 2 dx equals secant squared theta d theta. Okay, and the reason that it's 2x equals that is because remember, if we have a squared plus u squared, then we let u equal a tangent theta. And in this problem, see, the 4x squared, that's u squared, so u is 2x, and that's why we have the 2x here. Alright, now let's write our problem down again. So we have dx over the square root of 4x squared plus 1. And now all we do is substitute in. Okay, so dx, well, we have 2 dx. So what we need to do is take this and solve it for dx. So if we divide by 2, we get dx equals 1/2 secant squared theta d theta. Okay, so substituting this in for dx, we have 1/2 secant squared theta d theta over, and in the place of 2x, we're going to put tangent theta. So that's going to be tangent theta, or tangent squared theta, plus 1, and it's the square root of all that. Alright, so hopefully you see how we get the tangent squared, because remember, this 4x squared, that's 2x squared, and see, we took 1 tangent theta, or just tangent theta, and we put that in for 2x. Okay, and so that would be, that's where the tangent squared comes from.